So in statistics, we have a whole bunch of different terms, and I'm going to try to introduce you to those. That's why I like this one. My math teacher said I was average. How mean? Because we got the mean. Okay, so it is all about interpreting data. So we want to take a look at what kind of data we have and how can we make some conclusions about it. So for example, we can be analyzing, the age of the students in a class, or it could be lots of different things. We're going to see tons of examples. But let's start with the first one. We're just going to fly through a bunch of definitions. You might have heard them before. A lot of people have, but just to make sure, mean, that's the average. That's this average here. That's why that joke is there. Now, the kind of notation we use for this, we tend to use two different symbols. Your calculator sometimes uses this symbol right here, or we can use this one right here, which is Greek symbol mu. This is a common one here. I'll just write a little bit bigger like this. There we go. This right here is a common notation that we use, so that's a really important one, okay? So this is the idea. To find the average, what we do is we count up all the values, and then we divide by the number of terms. So let me show you what I mean sort of old school way, sort of by hand here. So let's say we wanted the mean here. Well, what would I do? The mean, I'll say, so this one here, mu, equals, let's see, it would be 2 plus 2.5 plus 4.8 plus 6.1 plus 0.5. And I would divide that by the number of terms. So 1, 2, 3, 4, there are 5 terms. This is how we do the average. Now, of course, you can get out your calculator to do it. So let's do that, just in case you felt like it. So you can say 2 plus 2.5 plus, let's see, 4.8, whoops, 4.8 plus 6.1 plus 0.5. So 15.9 over 5. All right, so that's the exact value. If I want to find the approximate value, then I just press this divided by 5. And it gives me 3.18. So there we go. So that means the mean, in this case here then, is 3.18. That's how we do the mean. Now that's a generic way to do it. We have a, sorry, that's a specific way. It's not very helpful. We're going to see a better version of that in a little bit. So we also have something called the median. The median is just the middle number if you write them ordered. So this is the pro tip for you, is that when you do the median, you need to write the different terms in order. So from smallest to largest. So for example, if I was trying to solve this one right here and say, what's the median? Well, it would help if I wrote them in order. So 0.5 is the smallest, then comes 2, then comes 2.1, then what, 4.8, and then 6.1. So there's 1, 2, 3, 4. There's 5 terms. So what do? The median will be the middle one. By the way, if there's 2 different terms like that, then you take the middle in between them. So let's say it was like 6 terms. You would take, the midpoint between the 2 in the middle. In this case, there's only 1 middle term, so we're fine. So the median is just 2.1. That's how we do that one. Okay, so that's the median. So far we've done mean. Mean is the average. We've got the median, which is the middle number. Now we've got something called the mode. That's just the most common one. So whatever happens most often. If you have a big table that tells you like the frequency of things, and it's the one that has the largest frequency. And the whole thing could actually be a group as well. So we call it the modal group. All right, percentiles. Those are really important here. Percentile is when we say like X% of the data is below this. So for example, let's say you're told you're in the 38th percentile. Well, that means that 38% of students are below you. Or you could say that, the opposite is true. So that would be what, 62% of students have a grade higher than you. So something like that. That's a way to look at it. 90th percentile, for example, this means that 90% are below you. Or you could say that, 10% are higher than you. All right. Quartiles, those are really important. We're going to be using these quite a bit, actually. So we're going to call this Q1 for the first quartile. We're going to have something called Q2, second quartile. We're going to say Q3 is the third quartile. See, if you think about 100 and you split it up into 4 even pieces, that's why they're called quartiles, because it's into 4. Or into quarters, you could think of it that way. So the first quarter, that's the 25th percentile. So in other words, here, if I go like this here, that means that, 25% of the data is below this particular number here, whatever that is. Whatever Q1 is, let's say it was like 15 centimeters. That would tell you that, 25% of the data is below that. Well, then we have this Q2, which is the second quartile, right? Because that's the, 2 times 25%. That's the second quartile, which is the 50th percentile. And we have another word for this one right here. We call that the median. Because remember, that's actually a really useful one here. This is the median, because that's the middle number. So that tells you actually something about the median, the middle value here. Now we've got the third quartile, okay, so 75th percentile. So this helps to know that Q3 is a 75th percentile. Q1 is the 25th percentile. Doing okay so far? We're going through a lot of definitions, I know. We're almost done. I like this one. It's my mode not to be mean. All right, we have something called interquartile range. See, in statistics, we like to not just look at what is the mean or what's the average. We like to say, like, how much are things spread out? Because you might have an average, but things, if they're really, really spread out, it's not a very helpful average. So we have some way of measuring the spread of the data. Now, the technical term is called dispersion, at least in mathematics. In physics, we have another word. Well, when waves are spread, we also say there's a dispersion in waves. But here we mean dispersion as in the spread of the data here. We have something called the interquartile range. This is on your formula booklet. It says it's just the third quartile minus the first quartile. So this is actually on your formula booklet. Yay. Okay, so that's really nice to know. So here I'll say formula. I'll just write like this, booklet. Oops. So I'll just write that down so that way you know this is on your formula booklet. Hooray, you don't have to memorize this, but I don't think it's so hard. Here's an example. You have a data set, 25th percentile is 42, 50th percentile 61, the 75th percentile, let's say, is 79. The question is, what's the IQR? What's the interquartile range? And just to show that to show someone that you know what you're talking about, you can write down the equation, Q3 minus Q1. We didn't need the 50th percentile or the median. We didn't need it. All we needed to do is just use these numbers here. So we have Q3, which is just 79, minus Q1, which is just 42. And so let's see, 9 minus 2 is 7. 7 minus 4 is 3. Oops, I just got to write it nicely. So it's 37. That's it for interquartile range. It's actually not so bad. So this tells you some idea about the spread of the data. All right. Now, last is the formal version of the average. Okay, so we've got this nice big equation right here. I want to show you how it is that it looks on your formula booklet here. So they write it like this with the X bar like this right here. Okay, and they write it like this. They say X bar, but that just means average. Okay, that just means the mean. They write this sigma notation here. Some people get really messed up by this just because they don't really know what to do with this. So I'll explain it in a second here. Let me just write it down. Fi, Xi, all that over n. They even tell you that n is going to be what? The sum. Oops. I'm going to make a nice equal sign here. Equals 1 all up to k of, well, all the terms. So it'll be Fi. There we go. What does this mean? A lot of people, when they see this equation, they just sort of want to cry. I just want to explain it. Hopefully it'll make some sense in a second here. Let me just spend a second explaining what this means. So what does this mean? The sum, that means add up, right? That means the sum, okay? Which means add up the terms. So this just means then you add up all the terms from 1 until you're supposed to stop, until k. Just tells you basically start where you're supposed to start, finish where you're supposed to finish. Count up all the terms. Do you notice what this says to do? It says multiply the frequency, that's what f is, times the x value. So whatever the x value is, there's going to be like a number of them. Maybe there's like 5 of them that are x equals 4. So you go 5 times 4. And then you'd add up, the next x value, whatever that is, times its frequency and so on. And you divide that by n. N is the number of terms. And this right here, this is just the number of terms. So you can think of it then, you just add up all the frequencies. That's what this means. Add up all the frequencies, because that will tell you how many terms there are. I'll explain that with an example in a second here, okay? So I'll just show you how to formally do it. So this, although the notation may look crazy, it is just doing what this example here I showed you before. You add up all the terms and divide by the number of terms. The thing is, what if you had a whole bunch of these? What if you have like 10 2's? You don't feel like going 2 plus 2 plus 2 plus 2 plus 2. Instead, we just say, there's 10 2's. So we say 10 times 2. And then we, do the next one, whatever this is. Maybe there's like 11, 2.5. So we go, okay, there's 11 times 2.5 and so on. So actually what we've just done here, this is just a formal mathematical version of saying do just that. Multiply every number by its frequency and add up all those combinations of those, divide it by the number of terms there are. Let's see if it'll make sense. So here's an example here. Got the height of dinosaurs. I think dinosaurs are awesome. So the height of dinosaurs are given by this. So h is between 0 and 10 meters. There's 5 of them. Height between 10 and 14, there's 2 of them. 14 to 18, there's 1. And 18 to 22, there's 2. How do I find the mean? Well, there's one way I want to show you first of all, is that when you have a range like this right here, I would say this, choose the middle. Choose the middle point in all these ones. Okay? Choose the middle points. In other words, I'm going to redo this table to make it a little bit nicer here. So I'll say h. So between 0 and 10, that'll be 5, because that's way easier to work with, because I don't really want to work with the rest of it. So I'll call that one 5. Between 10 and 14, the middle point is 12. 14 to 18, the middle point is 16. This one here, the middle point is 20. Now there's 5 of those, there's 2 of those, there's 1 of those, there's 2 of those. So how do I do this then? This is the frequency. I'm going to use that equation, really. I'm going to say, all right, look, the mean is going to be, I'm going to add up all the terms. I'm going to add up every frequency times every x. I'll start by the first one. I'll finish when I'm done. I'll divide it by n, where n is the sum of all the frequencies. So let's use this, because I think this can look really complicated until you actually see it in action. So there's 5, but there's 5 of them like that. So I'm going to go 5 times 5. Does that make sense? Because I got to do, there's 5. There's a height of 5, but there's 5 of those. It's like saying 5 plus 5 plus 5 plus 5 plus 5. So that's 5 times 5. Plus, well, there's 2 12. So I'll say, fine, 2 times 12. Plus, let's see, there's 1 times 16. So there's just one of those at 16. And there's 2 of them at 20. Whoops, that's not 20, that's a 2. 20, there we go. I'm going to divide all those by, let's see, how many dinosaurs are there in total? Well, there's 5 plus 2 plus 1 plus 2. These are the frequencies, right? So does that make sense why it's 5 plus 2 plus 1 plus 2? And we've actually done this. Do you see where we even said n is just the sum of all the frequencies? Look, didn't I add up all the frequencies? Look, that's what that equation said. N is add up all the frequencies. So if I do it like this, oops, then I can just do it on my calculator then. Well, 5 times 5 is 25. 2 times 12 is 24. 1 times 16 is 16. 2 times 20 is 40. All that divided by, let's see, that would be 4, 9, that would be 10. All right. I could say this right here. Let's see, this right here adds up to, what would that be, 40? That'd be 80. 105 over 10, I think it is. So I would take my 105, divide it by 10. I could do that on my calculator, or I could just know that I move my decimal over by 1. So I'd say 10.5 meters. So therefore, I could state without a doubt that the mean is equal to approximately, well, actually exactly equal to 10.5 meters. That is the average height of a dinosaur, according to this at least. This is the average height. Okay, so I hope that right there helped. It should make sense. Look, there's lots of them that are around 5. There's lots of them that are heavier, but not many that are less. So hopefully that makes some sense here. Okay, so when could you actually use this? When is this useful? Well, we do this so much of everyday life. We got biology, psychology. I mean, lots of studies that we do. You know, if you want to find out the averages, how people respond to things. Biology, the efficacy of drugs, for example, of drug treatments, like for example with COVID-19, all these things, we use stats for this. Sports, if you're looking at the analysis of how well sports teams do, or even individual results. Environmental studies and global warming, all this stuff. I mean, so much is statistics. So this is just an introduction, and we'll go into much deeper in other videos.